Okay, we're on. All right, good afternoon. We have our afternoon session beginning. We can leave the light on so we can see you. So we've got 3 sessions in the afternoon. We're live online. So Tony's got a session where we talk about Project Bernie and the school server that we'll talk about. We'll talk about that. And then we've got a session after this with microscopes, telescopes, some of the gadgets. And then we've got a session with our friends who are running a project in Tanzania. So that's what we have for the afternoon. So Tony, it's all yours.
Okay. As always, when I give these presentations, everything is falling apart. I was trying to make some last-minute change in the server. I think I probably broke it, but we'll see. What I want to do is to give you as much time actually on the school server as possible. When I say the school server, I'm talking about Bernie version, not XSCE, although the school software is now XSCE. But I think of the school server as something that delivers the content, and so therefore the content is essentially a key part of it. So on your laptops, what you want to do is to look for a network, SchoolNet M.
Can I do it on that?
Anything, yeah. It's got a browser, it works. So this is the school server. This is an Intel NUC, NUC, New Unit of Computing is what Intel's terminology for it is. These are built primarily for home computing or home theater market. You put this next to your TV, you run HDMI into your TV, and you can use this as DVR, you can use it for streaming, you can do whatever you want to with it. But we've kind of repurposed it as the school server because its size is great. And I think just a basic definition, a server in computing is a computer which responds to requests from other computers. And those other computers are typically called clients. So a client computer is a computer which responds to requests by humans. And they're really, in function, quite different. And so, for example, it disturbs me quite a bit when we talk about an XO 1.5 as a server, because an XO 1.5 is designed to be a client used by a human, and not to be like this thing in the back room somewhere. Now this thing right here is the router, so when you connect to SchoolNet M, that's where you're connecting to. But in an actual school, we would use a more typical TP-Link type of router that has the 4 Ethernet plugs in the back and antenna sticking up in the air, that sort of thing. But for when I'm traveling around, this is very easy to put in my suitcase and go with me. This NUC is a bit more expensive than what I would generally recommend, but right now it's the one that we can get off the market that works. This one with the Celeron processors would probably run about $50 less. But in any case, the school server together with the router should be coming under the price of 2 XOs, which right now would be about under 400. Although if we go by the Australian model, we can go up to 500 because they're going up to 250. So this guy has in it an 8 gigabytes of memory, and it has a 1 terabyte hard drive. We could go bigger, but right now we don't have a terabyte of data, so a terabyte's good enough. Memory in a server should be as big as you can handle because you use the memory in a server to cache the results of previous searches. So in the model that came up the other day here of you want 100 laptops to access Rachel in less than 60 seconds, my theory would be that if the teacher accessed Rachel first, the rest of them would get it in under 60 seconds because it's coming out of the memory of the server, not out of the hard drive or the SD card as they were using. And another problem, since this thing is not designed to be a server, it doesn't have very much memory. And so therefore there's not very much room to cache. So it's not going to handle a very big workload as a server. But the other thing is, aside from the fact that if you use this as a server, then you denied a child a laptop. But you really want nobody to pay attention to this thing, and since it doesn't have a monitor and a keyboard, they don't. Now, the only thing that the people in the school need to know from one end, from the start of the school year to the next, is at the end of the day, you press the power button, it shuts itself down. In the morning, you press the power button, it powers up. How do you know that it's powered up? If you can connect to SchoolNet-M, it's working. Because the address that you're using comes from the school server. It's called DHCP, and that's done by the school server.
So once we connect to SchoolNet-M on Wi-Fi,
Okay, now the URL you want to use is http://school server. And for all school servers, I tried to keep the name school server.
Is it all one word?
And so you should get a page that has two buttons, class and library. Now, if I do this thing, well, actually, I got this one buggered up, so that's not fair. Okay, let me talk a little bit about Bernie. All right, so we got a terabyte drive here. Downloading a terabyte from the internet in Africa is going to take about twice my lifetime. And so you don't want to do that. So in general, it's much easier to put the data on a 2.5-inch external USB drive and carry it to the deployment. Now, the goal here is that everything the deployment needs to set up the deployment should be here. So there are, in fact, 3 parts to Bernie. One part is the XO part, and this is the image for each of the 5 models of the XO. XO1, XO 1.5, XO 1.75, XO 4, and the XO 1 with a SD card, which actually is a different image than XO 1 native. So I have to have 5 different images. And then what the users do at the site is they have USB sticks. And so we give them instructions in Bernie how to copy the correct image onto the USB stick so that they can flash the XOs. In addition to that, there's a script, XO-custom, which you run after you've installed the software on the XO, which modifies Sugar to add some additional capabilities, such as the ability to play MP3 files, play MP4 files, some interface with the browser that you need to integrate better with the school server, and so on. And these are basically the same, except the ARM-based systems, the 1.5 and 7.5 and the 4, because they're ARM, you have to have different images because you're basically loading different dependencies in the image, and you ask different dependencies for things like the codecs and so on. And that was hard. But my goal is to make it as easy as it possibly can be for a deployment to set up their system. Now, as an example of the kind of problem you run into, on the XO 1.75, I noticed there was no volume control on the frame. Excuse me, what's going on here? So James Cameron said, oh yeah, we forgot that. So he sent me a new kernel. By installing this kernel after the image was loaded, I updated so in fact the volume control was there. Now, but the problem is today we put that on the table of the deployment saying, oh, you just need to update the kernel in the image. Excuse me, right? So we've got to do these kind of things before the deployment really has to proceed. Now you'll notice on mine, I have that page here. This page is actually local installed on the XO. Now most of you who have ever used the browser on the XO know you get this absolutely silly page with links to Google, links to laptop, and links to laptop.org, links to Sugar Labs. If you're in a system where you have no access to the internet, that page is totally useless. So we put a page that has some more sense, and this is what the students will see. Okay, let's start with the class. So if you click on class, this is really pretty arbitrary, and I think I'm going to put some more buttons to break these things out a little differently. But the original idea was, okay, if you get unable to load page, as I just did, what this tells the kid is that they're not connected to the internet, or not connected to the school server, I'm sorry. Which you do with the rightmost button of what's called the Zoom buttons, which shows you your environment. And right here I should, yeah, that's not it, because that's one. I'm the yellow guy closest to the X because it's the strongest signal because it's right there. And so all I have to do is click on that and say connect. And on the XO, what you get is that when you're connected, you get this circle with, it looks like a TIE fighter. You get two half semicircles, one on each side. That means that you're connected to that particular one. On the XO, if you press the frame key, you get this frame, which is a very important feature. Unfortunately, not documented as well as we'd like, but it's an important feature. And so down here, I also have the indication that I'm connected. And so that's what we do. The students say, it's not working. Check your frame, see if you're really connected. And in many cases, they're not. Okay, so getting back to where we were.
I have to start screening on 2 devices.
Good.
This one right here.
I'm not able to get it on my phone. It works on my computer. You were able to get it on your phone.
So Tony, I instead of going to the other one, I went to the library.
Okay,
I got some music.
which music?
Cheek to cheek.
There you go. This, on the regular screen, there's a block on the upper left-hand corner, and these link to data that's actually on the XO that's installed as part of the image. The mindset of the Sugar developers is that you're going to be using this neither connected to the internet nor connected to a school server. So they try to pack everything they can onto the XO, filling up the memory almost till there's no storage left. Which one of the advantages of the school server is you don't have that particular problem. So these particular songs and so on are kind of a sampler of what you might have if you had more storage space. And so these things really ought to be on the school server. Now this guy's not connecting correctly. Why is that? Moving right along. This said my track record on, oh, I somehow got disconnected. That's not it. Okay, disconnect. Okay, so in the class, there's a set of buttons. Each button corresponds to a capability. The Learn has got nothing on it at the moment. You click on Learn and you'll see there's one class, something about, I think, Kitty. It's not behaving. To blame George Hunt, he brought this from Adam. Yeah, I can't do that. Okay. Anyway, so in the Learn is where the teacher should be expected to have her syllabus, her course materials for use in the classroom. And I wanted to make it in such a way that at the end of the school year, that whole course gets moved into the Resources tab, which is the third one, or maybe I don't even show it on this one, but a Resources tab, so that when they're going into the next school year, they can take lessons that worked, and they can add new lessons if they want, and delete lessons that didn't work, so they can really recompose their course for the next year based on their previous experience. But it also allows volunteers externally to put things on the school server to add to the resources that would be available to the teacher to use in their class. So general rule, network on this thing is just not working.
Which one are you looking at?
So 1.5 that I got from Adam. We'll walk through it. You guys are looking at it, that's cool.
Well,
I sort of know what it's
it's
like.
on 2 iOS devices, but not on an
It
Android.
doesn't work on an Android phone.
Never got
I apologize.
Well, it works here on Chrome, but it doesn't work on there.
It hasn't worked on his phone or my phone or your phone.
It worked on my iPhone, not my Android.
Yeah.
And I haven't
It's a
tried-
website, so basically every
Yeah.
browser ought to be able to handle it. There's nothing really too magical in
It
these
has
things.
to do with DNS sometimes. I ran into this problem in Haiti Yeah.
Okay, I had that problem with one of these
What we ended
machines.
up doing was we changed the settings in our router so that there was a unique IP address assigned to the router and that fixed the problem. And then
Here we
instead
are
of
in a
typing
university
school
classroom with
server,
no blackboard, I'm then the whole
instead of
issue.
typing school server, we would type whatever IP address.
172.18.96.1.
What is it?
172.18.96.1.
Okay. That works.
And those of you that know about internet addresses realize that that's a
But
crazy
when
one.
I try to click on library, it
Yeah, you're really dead in the water because
creates a link.
the links are all going to say school server.
Yeah, so I would have to replace school server every
Yeah,
time.
now, in Linux systems, I don't know exactly how these things work, but there's a /etc/hosts. And if you put in there the 172.18.96.1 and then follow it up with the word school server, that's a DNS and it'll convert the name into the number. But I don't know if that works on the Android systems or not. 'cause
I
they're
mean,
kind of-
sometimes we say school server.lam, try that.
Yeah, that's another time that might work, because
Yeah.
the XSC people put that line in there, which is meaningless, but.
Say the
Okay.
address again. You don't need the address again?
172.18.96.1, which hopefully no deployment ever has to know, but there you are.
I learned.
Firefox adds a .com
That is school server.
at the school server. So Firefox on my Android phone adds .com to school server, so it tries to get to schoolserver.com instead of the local address.
There actually is I found there's a Firefox way to turn that nonsense off, but I did the same thing. It comes up with Time Warner dash something or other. And, because it's a research, if you got a 404, then it comes back and it tries to find something for you, and then you get up to some really bizarre place. And if you're out in the boondocks with no other internet access, then it really is frustrating, because then you've got to type in the original address again before you can try it. Okay. Anyway, so the other thing that's in Learn, which is much more important for the moment, is Explore. Now, the idea of Learn is these are the classes the kids are actually taking in school: English, math, science, so on. Organized by subject, course, unit, and lesson. But the unit is important because the way the lesson design is set up is we zip the unit and it downloads to the XO as a single file. So when the student goes to the next unit, they download the unit and they now have that unit, all of the content that they need to work with local. So if they go home or they're not connected to the server, they can still function.
And it happens all in the journal.
Hmm?
And they can access it from the journal. So it gets unzipped
Correct.
and it's accessible.
Now, it turns out the browser I have that you don't have, in other words, with your systems, you're just going to have to do it the hard way by hand. But on the XO, what happens is it comes down to the journal, and then on the browser, there's a button. They click that button, and it gives you an object view. You go to the journal, pick out the object that represents that lesson, you click on that, and it's now unzipped behind the scenes, and it goes to index.html in that folder, and then you've got HTML access to the rest of the lessons. Explore is similar. I haven't quite got it working in exactly the same way as Learn at the moment, but the goal of Explore is that these should be similarly formatted courses, if you like, but oriented to topics that are not in the standard curriculum. And being who I am, these are all basically programming. So the first one is called Hands-On, and that's the one I expect everyone to go through, because it explains the file system, which is essentially hidden to them by Sugar.
It's not found.
Yeah.
Yeah.
All of my demos go like this, but I have a backup this time. Another option you have is to go to HTTP on the internet. HTTP www.projectbernie.org. And I've got basically the same things represented there.
We have to disconnect from the server.
Correct. You have a choice between the server and the internet. Technically, if I put a USB to Ethernet adapter, I could plug into an Ethernet cable, and now you would have pass-through, so the internet would actually go through to your XO. But none of the deployments that I'm dealing with have any access to the internet, so I've never really gone through. I know it works because I've done it a few times, but not recently. But that works. But for a lot of reasons, you don't ever really want to use that because even if you have access to the internet, unless you're in the United States in Boston, you don't have enough bandwidth to have 100 kids on XO surfing at the same time. So
Oh,
my guess is what you want is the school server to basically do Copernicus type surfing or get downloaded messages from some central location, essentially not surfing, but the kids' access should be through just to the school server. Because in most of the Africa, for example, you can get access to the internet through the phone company, but you pay a lot. And the schools simply don't have a budget to be paying for so many gigabytes a month. So even when it's available, it's got to be a controllable resource. So if you go on the Project Bernie, there's a picture of Bernie and some words, but you go down and you see the same two buttons, and you just say the
Give us the URL again, please.
HTTP www.projectbernie.org. Should be the
I'm actually connected to your server. Maybe because I'm using.
connected here. You're connected to this guy.
Everything is.
Yeah, great. Okay, but what I do is when I install the software at a school, I customize it, which, for example, modifies the browser to provide this extra button that unzips content that's downloaded and a few other things of that kind. And you don't have that on yours. So some of the things I say aren't going to work because they don't work, and other things are not going to work because you don't have some of these customizations. Okay, so in Explore hands-on, this is explaining how the terminal activity works, which is the command line.
Okay, so, I'm sorry,
Yeah,
I'm so
go.
busy struggling to get
Yeah, I hear
to
you.
your server. I'm looking at class and library, where did you?
Class.
Okay,
And what I'm talking about now is under Explore.
okay,
And at
thank
the
you.
top of that, you should see one that says something about hands-on. But it may not show because that's what I was messing with, and I think I may have goofed it up. If you get one line and there's nothing else, then that's probably what's happening. Click on the class.
that's okay, I know. I did the same thing, that's why I'm entering it again.
And then try Explore. Yeah, it's the next one that may be the trouble, so you put it in like that.
Some things you can see and then others.
Yeah. So,
Yeah.
but they try to click on first course, that makes it actually work. There's an error in the HTML page. Okay, you have to go, yeah, I do this all regularly.
Goodness sake,
I should learn to leave hands off.
if it's working.
Okay.
Change your
Just
reference.
don't make it worse.
So anyway, I really would like to have people try this on the internet site. And my goal is, I think that kids, even primary school upper grades, 4th, 5th, and 6th, which is the target in Rwanda, can in fact learn a great deal. The reason being is that the laptop computer will work or not work depending on what they do. So they get immediate feedback as to whether they're doing it, following the instructions correctly or not. And I think that's what kids relate to. You know, if they're going to learn to ride a bicycle, they learn that they don't want to fall. So they get pretty good at it. Now, another thing is that I think fundamental to the OLPC program, when I'm giving workshops to teachers, one of the first things I say is, how many of you have a cell phone? Everybody have a cell phone?
Yeah.
How many of you attended a class or a workshop to explain how to use it?
The first time I got it, yeah.
And you're an
It was a long
exception,
time ago, but.
because we don't. How do we learn to use the cell phone? Trial and error, finding somebody else who knows how to do what we want to do. So this is collaborative learning, this is all the kinds of things we talk about. So I don't see any point in a school teaching how to use the computer. Beyond, they have to know how to open it, they have to know how to turn it on, they have to know how to start an activity, stop an activity, and shut it down. But they really should be using this to learn English, to learn math, to learn science, native language literacy, these kinds of things we've talked about. That's what it's for. But schools have this kind of unique blinders that this is the subject It's typically called ICT. We tend to call it computer literacy, but most of the rest of the world's ICT. And whenever I hear it, it's like fingers on the blackboard. It just, because if the kids for 3 years use this thing to learn English and math and science, they'll be so far ahead of their high school teacher, it won't be silly. I mean, they'll know it.
Well, there's another factor, which is the hypocrisy of, when you buy an iPhone, it's nobody's business what you do with it. If a poor kid gets a computer, it's everybody's business as to what.
Yeah, and not theirs. Yeah. And this is another thing that I have to tell the teachers right off is, you're hired to teach math, science, English. You are not hired to be a computer teacher. So if the kids know something that you don't know, pat them on the back, encourage them, tell them to go show the other kids what they did. And just don't worry about it as being a challenge to your expertise, because you weren't hired for that expertise. And the teachers have no more experience with computers than the kids, which is to say none of them have any. And this is hard for us to imagine because we grew up with this. Like, it amazed me, we brought in a bunch of second graders, and so they got the machine out and they're typing. Nobody ever explained that you have to curve the fingers. Well, it wouldn't have occurred to me that you have to do this, but in fact you do. So we have to have, well, another one, a typical urban legend-like thing is we don't teach the teachers well enough how to use computers before we turn them loose in the classroom. That's not been my experience. The teachers learn really quickly how to use the computer. The problem is they don't know what a computer can do. So the only thing they know about the computer is what you showed them, because they just don't have this culture of how the computers work, what kind of things can you expect it to do, how are they working. And in Rwanda, for example, the headmaster came over from the high school. He's now the principal at the elementary school. We need to teach ICT. We've got to teach ICT. What is ICT? In Rwanda, it's explicitly Windows Office. I mean, it's not an Office-like, it's not, a word processor. Microsoft Word, that's the chat, okay? And he wants the elementary kids, because that's what learning computers is all about. You have to learn Office. Right? Now, you think about this. How many employees who use computers in their daily work every day use any of Word, Excel, or PowerPoint? How many Walmart retail clerks are using Word? 0. They're using point of sale software, right? Do we teach point of sale software? No, we don't. And Windows is now about 4th in the popularity of operating systems, because I think Android's 1st, Apple is 2nd, and maybe Windows is 3rd. But it's no longer the dominant thing in the market by any means. But it'll take education a whole generation to figure this out and change, because they're always going to be that far behind, I suspect. Okay. All right, trying to go on with this. Okay, so Explorer is very important. And beyond the hands-on that everyone should do, there are 3 tracks. 3 different programming languages. One is Bash scripts. Bash scripting technically is a programming language because it has if and it has loops and it has everything. But it's also what people who work with computers in this kind of a world, we do it every day. This is the fundamental toolkit. It tells us how to get around the system, where to find files, how to erase them, how to move them, how to do anything with them. You really got to know that pretty well. But this goes on into how to make scripts, which is how to put together a number of these commands and operate them as a program. Goes into things like regular expressions, which is kind of a fun thing. And I can imagine the kids will really enjoy that, because a proper sed script is really almost a secret language. Python. Python is so much easier to learn than basic Fortran, Pascal, and almost C or C++, or you name it. Is a great place to start programming. Because it's really a very simple, straightforward, understandable way to do business. Now, as I make a big point in these things, you start out with Hello World. That's the convention today. And so we show them in each case how to make a Hello World program, and then go on from there. For example, with Python, one of the things you do right off the way is you show them how they can do their homework, right? Because print 2 times 2, 4, really easy. So the teachers may not be so happy with that, but the kids should be pretty well happy with it. But it turns out there are 3 books on programming in Python for kids written by Al Schweigert, who made them Creative Commons, which means we have total right to distribute them. So there are actually 3 complete books, and there's more. There's a 4th book, which is Thinking Like a Computer Scientist, the Python version, which is also Creative Commons. Quite different perspective on learning Python than the other 3.
Oh, this is like a question for when you're done with the introduction.
Or as you wish.
Good?
Yeah.
No? Okay. Have you looked at Code.org and Codecademy?
Yes.
Like, that's how I learned how to code. I don't know about
Yeah.
learning, but like. I
This
do know
raises an
something.
important issue
Yeah.
because one of the goals with the school server is to fill it up with good stuff.
Right.
But
and
one of the
books are
problems,
not a good way to learn how to code.
yeah,
You know?
what?
Like, reading a book is.
No. Let me, I'll get that. What's important to remember here is
Yeah.
you can have free content on the internet, like Codecademy.
Yeah.
But you don't necessarily have the right to put it on your machine and make it available to others.
So we talked to Codecademy and we do, but Codecademy involves Ruby on Rails. And
Yeah.
the guy who wanted to make this happen did not know Ruby on Rails well enough to make it happen.
Yeah.
So.
But this is the point, though. If somebody says, hey, I really want to have X,
As such,
Then we can find out how to do it.
Chicago, they're just
I
getting.
mean, it's still a computer. We do it. Now, these 3 books, what he did was, he takes a small program, he shows them when you run the program, here's what happens, then shows the text of the program, and then explains the text line by line, and then, okay, change the program, modify it, do something with it. There are really 2 kinds of programming books, or even computer books, if you like. There's the encyclopedia, and there's how to do something real. And this is one of the how to do something reals. You can get Python reference books, and they start from A and go through to Z. The problem with those is that they're great to have in your pocket when you can't find something out, but now the internet tends to be a better way to do that. But if you're going to learn a language, you have to learn it by doing. Really, that's where it's at. You've got to do it. So we've got to get the kids hands-on, which is the whole idea of that part of it. And so this one, he's taken small chunks. He starts out with the whole world. I think the next one is estimating a number, guessing a number between 1 and 20. Now, these programs in this first book, which is called Invent Your Own Games in Python, are text-based games. You have text input, text output. That's how we started. We used to, that's the only thing we could have, was text in and text out. But from a programming point of view, that eliminates a lot of complication that you can put off to later. The second book is a brilliant concept. It's on hacking with Python, creating secret code, figuring out how to hack the secret code, how to decode the messages. And of course, I think kids at the primary school level to upper grades be all over that. And both of those are beginning, so they could start learning Python with either of those 2 books. They both have the same style. Here's a program, here's how it works, here's what the Python is doing, and then introducing Python concepts kind of step by step. The third book is how to use Pygame to make graphics games. And that's a little bit trickier because you're bringing in a big Python package that knows how to do all kinds of things on the screen, and then learning how to do that, how to have your game make sounds, how to have your game, how to have objects move, how to have them hit borders and bounce, and a lot of things that are very useful for them to learn, and much more interesting because now the games are really looking like something that has some excitement to it. The Thinking Like a Computer Scientist is more not how to do particular programs, but more how Python structures fit into the global ideas of loops and decision ifs and nested ifs and those kinds of things, but you end up at the same place, so it's another option to go ahead. Now, I've put an outline in there that there's one more course we need, which is how to write sugar activities in Python. And what I'm planning to do there is start out with, okay, you have Hello World over here. How do you make Hello World as a Python activity? What do you have to change? And then maybe go on and take some of the other ones and say, have the kids make a game, or make the game a Python sugar activity. Then they put it in the home view on their computer, and they can play it right just like any of the other activities, or upload it to the school server, and other kids can download it as they choose. Now the third track is web technology. So this is HTML5, CSS, and JavaScript. The book for JavaScript called Eloquent JavaScript is an excellent book. Creative Commons, I don't know how we do this, but he did. And it's really a very well-respected top book, but it treats JavaScript as a programming language, where most of us approach JavaScript as a way to make your web pages move, right? But he starts out with how you do the same things you do in Python. How do you do Hello World? How do you do this? And his output is what we call a console log output, which basically says in the debugging section, tell me what happened. But nonetheless, the kids can see, if I do the program, this is what happens. And then he introduces HTML and CSS in the JavaScript context, about chapter 6 or so. He's got a couple of chapters on Node.js, which is a way to write JavaScript programs that can operate independently of the web technology and so on. But not written for kids. This is written for adults, no question. So the trick is, how do we make it possible for the kids to see whether they're doing things right or wrong? And so in the Google Summer of Code, Rich Asego created a JS Fiddle kind of capability for the browse activity, so the kids can type in and then just click a button and see what the web page would look like corresponding to what they've done. So they could change the CSS to make the background red or green or blue and immediately see, it didn't work, and so on. So, and same thing with the JavaScript. If they say in JavaScript 2+2, they can see the output in the window for the console log 4. So they can get that interaction. It's much more important with this Eloquent JavaScript book. But I'm very interested in feedback from people as to whether they think kids can handle this. I showed this to TK Kang in Malaysia, and his immediate response was English, because there's a lot of text. And so for people who are not native English speakers, this is going to be difficult. And I think we're going to have to go back and make it shorter text to get them to something that interacts and so on. I took out, for example, all of these textbooks start out explaining how you install Python on your Windows machine. That kind of context we don't need because we've already got it installed. We just need to tell them where it is and how to get to it. So there's some customization that really was needed to make it more fit for that. I spent a lot of work on that. Okay, now also on that page, or if you go back to the class page above the Explore page, the next row you have Khan Academy, which hopefully works, should work. I think that's the most powerful curriculum-based tool that we have, because with this you can do exercises to establish that you know the arithmetic being taught in the primary school, through fractions, decimals, everything up to including pre-algebra. Actually, it goes beyond that, but I don't think we're going to get the primary kids up into trigonometry necessarily. But I think it goes as far as differential calculus. And I've got a version, they've changed it. I've got to go figure out what's going on here. But this one has got a star field. And as you go to the top of the star field, these are where you should start. And the way it works is you pick on an exercise. Actually, I usually start with telling time, because that's not in the mainstream, but it demonstrates how the exercises work. So if you click on telling time, you get 3 exercises. You're supposed to do the first one, second one, third one. When you do one, you have to get a certain number right in a row, typically something between 14 and 20 in a row, correct. Now, if somebody can do one of these problems and they get 14 to 20 in a row correct without making a mistake, they've got it, right? And what happens is that there's like a progression bar that shows how close they're getting to succeeding. When they reach the end of this, they get proficiency. Well, unfortunately, this particular version doesn't feed back very well to the kids, but the teacher has access to a report called the coach report. And this has on the top the exercises in that particular area, like addition, subtraction, or multiplication, division. And then all the students' names along the left, and the box in the table has a color. If it's a white box, it means they've never done it. If it's a light green box, it means they've tried to do it, but they didn't reach that 20 in a row or 14 in a row level. They got somewhere, but they didn't finish it. If it's a dark green, they finished it. If it's a red, it means they've tried 2 or 3 times and they haven't succeeded. So this is kind of a flag. Now, 99.9% of the time, it's going to be they didn't understand how the exercise works, not they didn't understand the technique. And then the teacher needs to go back and say, oh, here's what you should be doing. Give them a couple of examples, get them started, and after a while, they'll get it. It's also an opportunity for the teacher to take some kids that's got a lot of green and send them down and work with some of the kids that got red, which is what teachers should be doing, I think. But it covers everything. So I told the teacher, I said, look, if your kids can get solid green on all of these exercises, probably 150, they're going to pass that 6-year leaving exam in math. And that happens to be the worst in all of Rwanda. I don't know if it's because the test is harder, the subject is weaker, but nonetheless, the lowest scores on these tests uniformly are in math. So I think they need help there. But the Khan Academy is beautiful. So what I really want to do, and I want to talk about what needs to be done with the server. I'd like to extend this capability to all of the other activities and other subjects so that sugar activities can report back to the teacher what they've done, what they haven't done, how well they've done, and so on. And I've got a lot of that in place. Okay, now, beyond Khan Academy, we have Moodle. And when you open up Moodle, you should get a page that asks you for a name and password. It's admin and admin. And when you enter admin and admin, you'll be the admin, but you'll also see what's there. Now, when we distribute the school server software, Moodle is installed, but it's totally empty. There's nothing there. What I did with the teachers is they have to have a scheme of work. So this is basically what they're going to do each day in that class during that term. And they're required to have it because inspectors can come and say, show me. And so most of them have a big 3-ring binder, which they mark up and so on. But I said to them, you know, you can put this on the school server, and it'll be there from year to year to year. And you can edit it however you choose and so forth. Teachers being teachers didn't have time to really do that, but they thought it was a good idea if they ever had time to do it. But I put in there, what's important is in there are all of the curriculum requirements for Rwanda, English, math, and science through grades 4 to 6. So this is what we need to have educational content to address. So it's useful, I guess, from that point of view. There's been a lot of discussion on the mailing list about why do we do Moodle, why don't we do Moodle, what's going on. Well, one thing you can say is it's designed for university students. Okay, one of the downgrades of the design for university students is 50% of the code in Moodle is designed to prevent you from looking at the course if you haven't paid the fee. Okay, so consequently we have Moodle, which is open source software project, but the content of Moodle is proprietary. I haven't been able to find well, there is one set that One Education in Australia they teach their teachers with Moodle. But I haven't been able to get them to release the courses so we could use them. Oh yeah, they're Creative Commons, okay, well. But you have to have the file in order to load it into Moodle, otherwise you can't use it. But here's a book from Pact Publishing on how to build courses for 7 to 14-year-olds with Moodle. So it can be done. Moodle is very easy to build course materials. After you've done a few, however, it gets very repetitive because you've got to go through their whole cycle every time. So it makes it easy as possible for the teachers, but once you get to be a little bit confident in how to do it, it's overkill. But so it can be done.
Who's the author? Who's the author?
This one, Mary Cooch. PACT has a whole bunch of these Moodle things. This happened to be, I picked it up because it's 7 to 14-year-olds, but they have a how to do math in Moodle, and so on. How to administer Moodle, so on and so forth. But my experience with it in doing these statement of works was, after you've done a few, it really gets to be painful to do it. But for teachers who don't have a lot of experience, it's easy. In fact, I had the teachers, they initially, I said the easiest way to do your lessons is do them on Moodle. And I never could get them off Moodle after that. I had to cut and paste off Moodle and put them into that learning capability. The third one that's on there is Khan Academy Moodle. What's the third one? Oh, EPAT activities. These are interactive Flash activities, mostly Flash, from Oli Nepal. Now, the Oli Nepal's philosophy is they're providing educational resources to supplement the textbooks. So they're not trying to be comprehensive and cover everything in a course, but where they think they can make additions that are helpful. And the way they've organized it for the teachers is by subject, grade, and week in the school year. So if you look at that, you pick grade 2, you pick English, week 4, there'll be 1 or 2 activities available for that week. They're all interactive activities, excellent in general. About 70 of them are in Java and HTML5, because these were done as the very first ones using eToys, which is Smalltalk. And they discovered that they took too much memory and they were too slow. So they redid them as HTML and JavaScript.
4 minutes.
4 minutes. Out of my 45, I've used 41. Ooh,
Many.
we haven't even got started yet. We haven't been on the library side at all. Oh, well. Okay, 2 things that I really would like you to look at while we're one on this page, which is home view. So if you have home view, this is on the class page, click on home view, and you'll see an emulation of the home screen. Okay? Now, if you click on any of the activities, what you're going to get is a slideshow that shows you how to use that activity. Now, it doesn't have arrows, so just the right arrow takes you to the right, the left arrow takes you back, so you can go through. I spent about 3 months, I think, doing these things, but nobody's used it. Now, there is a theory in OLPC that kids should find out all this stuff on by themselves. I don't know how they do it when they only have the access to the machine for 40 minutes, but okay. But in any case, I've got the ones that were sort of in the main set at the time. Some of those have changed, but I think Labyrinth is there. Paint is there. The eToys I put in the Wave Place videos. I don't know if those still work or not. I've done that for some time. So this is one thing, but I think what I'm really getting at here is we need to put the information for the teachers who are using the laptops on the laptops. What we typically do is I'll be giving a class like this and I'll say, okay, is your page on this yet? Are you here? You know, and you walk around. And so I'm giving a lecture, and then maybe I'm giving a paper handout, but that's a classic way we're trying to tell people, don't teach that way. Use the XO, and we don't even use the XO ourselves to teach the teachers. We need to, because when we leave, which we do almost immediately, they need to have some resource to go back to, and we need to give it to them. So this is one approach that I've taken to try to accomplish that particular thing, but it takes a lot of maintenance. I did one that was like the floss manuals. If you click on the center of that where the XO is, you'll get the floss manual. Trust me, it's true.
Which one?
On the home view,
Oh, I don't have
you don't have home view.
On what? Which device?
Well, from the class page, you click on the home view button.
Server error on home view.
You know,
It
this
never, home view always works. Of course, when I'm taking the demo, then.
Oh, you mean on the
Silver.
okay,
Always.
okay, I've got
Internal
home view,
server
it's beautiful, but,
You-
oh, it might work on the iOS.
Okay. You're a project, aren't you? Okay.
An archaeologist, it's like discovering an artifact.
Working on it.
Oh, okay, this
There we
is-
go.
Okay, on the Bernie internet page, there's a page that says guided tour. This was an attempt to update some of the information, which never got completed. It says plus or something there. Let's see what we want to do is get back to the class page.
I got this page here.
Here it is.
Tony,
Is that the one you're looking for? It's like, if I hit the
Yes,
Excel
yes,
button.
that's, you did on the XO, right? Yeah, that's it.
That's what-
Okay, so each of those 8 buttons takes you to a chapter from the PLOS manual.
Oh,
So it's all there.
let's see if it'll go or if it'll get in.
I'm on the class page now.
Okay, you're on Explore, which is a great place. If you go back, I tell the kids, just go back.
There's nothing there, I
This
mean.
is gonna get, so you have to go back to school service. This is the one that on their system.
Hey, Tony?
Well, we'll go and start the broadcast and then, continue with looking at,
Okay.
just to keep up with.
Sorry.
Well, I